Building RAG evaluation benchmarks manually is slow and inconsistent. Every question needs to be grounded in real source documents. DatasetOps Autopilot automates this end-to-end. 5 specialized agents, 2 human checkpoints, and a bounded repair loop for quality control. Under the hood, this is powered by 5 agents working together: source understanding, intake planner, benchmark generator, quality evaluator, and exporter, coordinated through shared pipeline. Let's see it in action. We start by configuring our workspace. We name the project, upload our source documents, a synthetic policy corpus you can find in the test docs folder on my GitHub repo, and describe the benchmark request. This is the autopilot engine, where the multi-agent workflow runs. Up top, we have live progress active agent and a repair counter. Below is the execution graph of our 5 agents, with edges labeled by the actual data passed between them, like source report or approved plan. Below is the trace panel showing every state transition as it happens, proof this is real execution, not a staged animation. Following that trace, the first node it logs sits just outside our 5 core agents, a pre-processing stage that gets raw documents ready before any agent reasoning begins. Here, we see how documents were parsed and chunked, the chunking parameters, and the embedding model used to index everything for retrieval. Once this is done, every downstream agent queries against it, starting with the first one. Now, this is our first agent, a source understander. This is where document analysis actually begins. It reads through all the parsed chunks and produces a structured summary of what the source material actually contains. On the right, it runs a knowledge coverage audit, sorting topics into strong coverage, weak coverage, and gaps that aren't covered at all. That's not just a nice to have. This directly shapes what the intake planner can realistically build a benchmark around downstream. And scrolling down, it also flags document-level quality issues, things like fragmented chunks or duplicated sections, plus optional planning recommendations it can pass forward to the intake planner if something needs adjusting before generation starts. Next is the intake planner. This is where the ambiguous request gets turned into a concrete plan. It defines the benchmark goal, the target language, and evaluation domain, and then builds out the actual blueprint. How many QA pairs, and the difficulty split across easy, medium, and hard. It also sets the quality guardrails generation has to follow, including a minimum share of unanswerable questions to test for hallucination. But before generation can actually start, this is our first human checkpoint. The workflow pauses here and waits for approval. Let's go ahead and review the plan. This is the human checkpoint in action. Everything the planner proposed is laid out here for review before generation starts. And it's not just a rubber stamp approval. Every field is editable, including the difficulty split, which validates in real time. So if something needs adjusting, we can change it here, save, and only then hit approve and generate samples. That's what kicks off generation downstream. With the plan approved, generation begins. This is the benchmark generator, and it's where the actual QA pairs get synthesized from the retrieved chunks.
Every generated pair is browsable right here, filterable by difficulty or searchable by keyword. Each sample shows the question, the expected answer, its category and difficulty, and what type it is: single hop, multi-hop, edge case, or unanswerable.
Every sample also comes with its grounding evidence and the exact source chunks it was built from, so we can expand and verify the answer traces back to real document content, not the model's imagination. Now, here's one of the core technical pieces of this system: the negotiation loop between the generator and the evaluator. This isn't just a retry, that's a bounded generator-critic exchange. The evaluator sends back a specific repair instruction, the generator fixes exactly that issue, and the sample gets reevaluated. This can happen a few rounds, and only if it still doesn't pass does it escalate to a human, instead of looping forever. It's what lets the pipeline self-correct autonomously without a person babysitting every single sample. But we're never locked out either. A stop button lets us pause or halt at any point, and the backend checkpoint safely so we can resume right where we left off. And here's our second human checkpoint. And after evaluation, we've got one sample waiting for review. Let's go take a look. It drops us straight into the samples that actually need a decision. Everything else already passed automatically. Let's flip over to pass for a second to see what the evaluator actually checks. Every sample gets scored across faithfulness, relevance, precision, novelty, and hallucination risk. And it writes out its own reasoning, not just a number, explaining exactly why it made that call. All right, back to the sample that still need us. We can go through these one by one, approve, reject, or edit each, or just use bulk actions if we trust the evaluator's calls here. And finally, the export package. Everything we approved gets compiled here. RAG-eval, answer key, a dataset card, and a quality report, all previewable right in this Explorer before downloading. The dataset card, for example, summarizes exactly what we just built. Categories covered, difficulty distribution, sample type breakdown, a full spec of the benchmark at a glance. Let's download the package and create the next one.